Okay, so this is the key to worksheet number 3, dealing with radicals, and in this case we're dealing with square roots. Now it says that we're going to add or subtract as indicated, and then for those with an asterisk, show your work, and then show that you are using the product rule when you show your work. Okay, so number 1, we have this. We have the square root of, 8 square root of 5 minus 5 squared is 7, minus 6 squared of 5, plus 8 squared is 7. So let me go ahead and just rewrite this over so it looks a little bit bigger. So number 1, we have 8 squared of 5 minus 5 squared is 7, minus 6 squared of 5, plus 8 squared is 7. Okay, so what I want you to notice is that first of all we have to simplify the square roots. So notice that I cannot simplify the square root of 5 because the only perfect square that goes into 5 is 1. Same thing for 7. There's 5 again, and same thing for 7. So I cannot simplify the square root of 5, the square root of 7, square root of 5, square root of 7. So now we're going to combine like terms. So remember, when we're combining like term with square roots, we're dealing with square roots now, and there are no variables here. So like terms would be the ones that have the same radicands. So like square root of 5, 5 is a radicand, and then 5 is a radicand here. So we have 8 of these minus 6 of these. So 8 squared of 5 minus 6 squared of 5. So remember that you got to think about what we have here. 8 squared of 5 minus 6 squared of 5. So if you want to think about this in terms of a GCF, so you see they have a GCF of square root of 5, right? So I can write the square root of 5 times 8 minus 6. And so 8 minus 6 is 2. So this becomes 2 square root of 5. But you did not have to do that. You did not have to do that using that distributive property. 8 subtract 6 is 2, so you have 2 of them. So we have 2 square root of 5, and then do the same thing with the square root of 7s. So we have negative 5 square root of 7 plus 8 square root of 7, right? So negative 5 plus 8, most of you know, is 3. But if you want to factor out the GCF, you can. That'll be the square root of 7 times negative 5 plus 8. So remember, if you distribute, you get this back. Negative 5 plus 8 is 3, so you get 3 square root of 7. And so that's going to be plus 3 square root of 7. So there's your answer. Now, if you want to put the square root of 7 first, you can. So you can say 3 square root of 7 plus 2 square root of 5. Does not matter. All right, so that's answer number 1. So number 1, you have 2 square root of 5 plus 3 square root of 7. All right, number 2. Number 2, we have the square root of 2, that's a 2, plus the square root of 72. Again, there are no variables involved, but we do need to see if we can simplify those square roots. Square root of 2 I cannot simplify because the only perfect square that goes into 2 is 1. I can simplify the square root of 72 because 36 goes into 72, and 36 will be the largest. So I have the square root of 2 plus, I'm using product rule here, so it'll be the square root of 36 times the square root of 2. And then 36 is a perfect square, so this becomes square root of 2 plus 6 square root of 2. And then now notice that these are like terms. This coefficient right here is understood to be a 1, so 1 square root of 2 plus another 6 of them gives me 7 square root of 2. So that's answer number 2, so it'll be 7 square root of 2. All right, number 3, we have, for number 3, I'm going to go ahead and just write it here. For number 3, we have negative square root of 8 plus 6 square root of 2. All right, so I want you to notice, see that second term, the square root of 2? I cannot simplify that because the only perfect square that goes into the radicand is 1. But I can simplify the square root of 8, negative square root of 8, because 4 goes into 8. So I can rewrite this as negative square root of 4 times square root of 2, because 4 times 2 is 8, plus 6 square root of 2. Now square root of 4, 4 is a perfect square, so the square root of 4 is 2, so you get negative 2 square root of 2 plus 6 square root of 2, and now those are like terms, and so I have a negative 2 plus 6, which is a positive 4. I get 4 square root of 2. So that's the answer to number 3. So 4 square root of 2. All right, now number 4 has an asterisk, so I got to show the work. So even though the work you got to show is kind of like what we were doing here. So number 4, you have 5 square root of 98 plus square root of 72. Oops. Where did I? All right. So you have the square root of 72 twice here. All right. So whatever you put here, you put here. But here's the work you would show. And remember, in the directions they use a product rule. So you got to find the largest perfect square that's divisible into 98. That goes into 98, right? And so in this case it'll be 49. So we have so what you have to do is write this first. You got to say 5 since the directions does say. Remember the direction says show that you're using the product rule. All right, so what that means is that I have to see that you are saying the square root of 49 times the square root of 2. Okay? Plus, I have to see that you are saying the square root of 36 times the square root of 2. All right, now let's simplify. I get 5 times 7, square root of 49 is 7, times the square root of 2, plus 6, square root of 2. The square root of 36 is 6. 5 times 7 is 35, so you get 35 square root of 2, plus 6 square root of 2. And now these are like terms because they both have square root of 2's. And remember, there are no variables here, so that makes it easier. And then all I do is add 35 plus 6. All right, and so the 35 square root of 2 plus 6 square root of 2 will give me 41 square root of 2. So that's the answer number 4. There's the work. 41 square root of 2. All right, number 5. All right, so here, let's put number 5 here. So number 5, we have the square root of 45 minus 7 square root of 20. So again, notice there's an asterisk. So there's an asterisk in all the remainder of those. So we need to show the work. All right, so using the product rule, so I have to see this. So this is what you should have said. You should have said, well, the square root of 45, the largest perfect square that goes into 45 is 9. So that's going to be the square root of 9 times the square root of 5 minus 7 times, and then that's going to be the square root of 4 times the square root of 5. The largest perfect square that goes into 20 is 4. And so now the square root of 9 is 3, so this becomes 3 square root of 5 minus, and then that's 7, and we can just go ahead and rewrite it. 7 times 2 square root of 5, and then 7 times 2 is 14. So I get 3 square root of 5 minus 14 square root of 5. And then notice 3 minus 14 is going to be a negative 11 square root of 5. All right, so that's answer number 5. So negative 11 square root of 5. Okay, number 6, we have 8 square root of 48 minus 3 square root of 27. So again, we got to use the product rule. So the largest perfect square that goes into 48 is 16, right? So I'm going to get 8 times the square root of 16 times the square root of 3. 16 times 3 is 48. For 27, that's going to be the square root of 9 times the square root of 3. And so I get 8 times the square root of 16 is 4 times the square root of 3 minus 3 times the square root of 9 is 3 times the square root of 3. So you have square root of 3's in both of those now. So those are going to be like terms. 8 times 4 is 32, so you got to rewrite that first. 3 times 3 is 9. And so therefore, 32 square root of 3 minus 9 of them, 9 square root of 3, will give me 23 square root of 3. Okay? All right, so that is the answer to number 6. All right, now again, if you want to, just remind you, some of you may need to do this, and it's fine if you do. So this part here, if you think about it, so the GCF here is square root of 3, so I can factor out the square root of 3, and I get square root of 3 times 32 minus 9, and then 32 minus 9 is 23. So I get square root of 3 times 23, but we always put the radical last, so it'll be 23 square root of 3, and that's what you had here. Okay? And then, so that's the answer to number 6. So number 6, we get, what's that, 23 square root of 3. And then finally, number 7. So number 7, we have negative 3 square root of 2 plus 7 square root of 8 plus 4 square root of 27. All right, so I cannot simplify the square root of 2, but I can simplify the other square roots. So I'm going to get negative 3 square root of 2 plus 7 times, all right, now let's talk about the square root of 8. So what's the largest perfect square that goes into 8? That's going to be 4. So using a product rule, you're going to say the square root of 4 times the square root of 2. plus, let's look at the third one. 4 times, again, in this case, will be 9. 9 is the largest perfect square that goes into 27. So I'm going to rewrite this as the square root of 9 times the square root of 3. All right. Now, let's go and go across and from left to right and see what we can do. So I get negative 3 square root of 2 plus 7. Now, 4 is a perfect square, so the square root of 4 is 2. I cannot simplify the square root of 2, so I'm going to rewrite it. Plus 4, square root of 9 is 3. I cannot simplify the square root of 3. And so then I'm going to get negative 3 square root of 2 plus 7 times 2 is 14. So 14 square root of 2. 4 times 3 is 12 plus 12 square root of 3. Now I have three terms, right? This one, negative 3 square root of 2, a positive 14 square root of 2, and a positive 12 square root of 3. Which of those are like terms? Only these two, because those two are the ones where the radicands are the same. So a negative 3 square root of 2 and a positive 14 square root of 2 is 11 square root of 2, and then plus 12 square root of 3. And that's all you can do there. That's your answer. You cannot see, these are not like terms because that's the square root of 2 and that's the square root of 3. So it's like saying 11x plus 12y. You know you cannot 11x plus 12y. You know that those are not like terms. So you can't combine those. Okay, so that's the idea there. Okay, so that's the answer to number 7. So number 7, we have 11 square root of 2 plus 12 square root of 3. All right, and so that's going to be the key to radicals number 3.